Is it true that every single electron in the universe
Mm.
is the same one?
What we know for sure is that every electron we've ever measured is exactly the same.
The same. Okay.
There is no property about one electron that is not precisely represented by other electrons. So we have to ask, does that require an explanation? We might ask. Or do we just allow there to be all these electrons in the universe made in whatever way they got made and they're all exactly identical? The question was posed, maybe they look identical because they are the same single electron. How might that work?
Yes.
Please. Yes.
Yeah.
How?
Okay.
How?
Now, right. Now we're getting to the good stuff. Yeah.
Within a couple of years, it was discovered. We discovered the antimatter particle to the electron, which we call the positron. Okay. And that's weird because all the properties are like the inverse of the normal particle. Is there any way to understand this? And it turns out one can interpret antimatter in certain situations as ordinary matter moving backwards through time.
Whoa. Wow.
Okay. It solves some equations regarding antimatter. So if you allow that, then you can ask the question, if one electron goes forward in time and then reverses going backwards in time, and it just keeps doing that, then wherever you are in time, you will see this record of electrons moving forward and backward in time in the instant that you make the observation. No, you have to pick me up from
You did it.
Where I'm a little fuzzy are some of the electrons we're looking at actually ones going backwards in time that we happen to catch in the moment we measured them, thinking they are ordinary electrons going forward in time?
Probably not. At this point, the reason we say probably not is, well, aside from the fact that we haven't been able to prove that experimentally.
Wait, don't disprove it yet.
Okay.
Just give me the full hammer of the explanation that accounted for every electron being identical, and then we can debunk it afterwards.
Right. Well, it has to do with relativity, right? Because you're moving forward and backward in time, being able to think of world lines in special relativity of particles. Now, if you imagine that things would just keep going past, present, back and forth, but you do it almost infinite number of times, then every time you measure an electron, it's the same one, but just at a different moment in time. It's a different part of its world line.
Oh.
So it's always coming backward and forward in time, right?
Okay, but so there's the electron that's in my experiment, but now I look out the window and I see a tree. That tree has electrons in it. So the electron that's in the tree and the electron that's in my experiment, it's the same electron just on a different world line that's crossing my present in a different location.
Yes. Beautifully said.
Ooh.
That sounds crazy.
Yes.
I'm just going to be honest. That sounds insane. Okay.
Well, a lot of things that sound insane when they're originally proposed turn out to be indeed insane.
Not that insane.
A lot of the stuff, though, you have grains of truth from which reality can then be further explained by it.
You had me up until the electrons going back and forth in time on a different world line in different places at the same time.
Yeah.
That
Because Chuck, the whole point of a world line is time
it's
is just
yours.
one coordinate.
It's yours.
Wait, hold on.
It's okay. Go ahead.
Hold on. Time is just one coordinate.
Right.
So two world lines can exist in the same time, but not in the same place. That's why you can cross the street
Right. Exactly.
and not get hit by a truck. In that case, you're in the same place, but at different times. Okay?
Okay.
Only when world lines actually intersect are you in the same place at the same time. And so all these other world lines is a different world line in an infinite number of passages through our universe. So our universe would be the construct of not an infinite, you can probably number them, but a hugely high number of passages of a single electron.
Okay. So do any of those world lines ever intersect at any time?
Well, we can smash two electrons together.
Okay. So then how's that the same electron? Boom. Nice. For the win. For the win. That's what I was saying. It's insane.
Charles, get me out of that one.
No, it's because you're traveling backwards and forwards in time. If Wheeler was correct in his hypothesis, because you're going forward and backward, you're literally crashing one of them that's going forward with one that's going backward, creating an annihilation, antimatter basically, positron kaboom kind of thing. So the electrons, if one electron hits the other, they're not actually hitting like we think of like two rocks hitting each other, but their wave functions are interacting in a specific way. So you see, it was an imperfect hypothesis or model to begin with. It's true, but you squirm your way out of it using quantum physics. And the idea that time is this dimension that you can go backwards and forwards. It's the melding of special relativity and quantum physics, electrodynamics.
I would love to know what the both doctors think is the greatest achievement in astrophysics of all time. And then he puts in brackets so far.
If we're talking about in my lifetime, the greatest achievement that has enabled other achievements on a way that nothing else has been able to, it is the successful design, construction, launch, and operation of the Hubble Space Telescope.
Okay.
It is the thing that has enabled more discovery in astrophysics than anything else in my lifetime. If we need to talk about just the ultimate discovery, the thing that sort of is the most fundamental thing in astrophysics, period, I think it is the confirmation of the existence of the Big Bang, a thing where the universe was once small and is now large, that there was a moment where you could extrapolate to a time equals zero from which everything we see and know has evolved to this point. How the specifics of the Big Bang, we still don't know. There's still a lot of things that are like in there. It could be a cyclical Big Bang, could be an inflationary Big Bang, but there was a Big Bang.
And the reason there was is because we can see it, right?
Yep. The cosmic microwave background detection, the expansion rate of the universe accelerating, the nucleosynthetic relationships of how much hydrogen, helium, and other elements there are in the universe, all of that conclusively, with beyond a reasonable doubt.
And the reason why I said that is because there's a lot of people who say that that is the religious leap of faith that you guys as astrophysicists make, which is juxtaposed against the leap of faith that people make when they say, well, there was a creation or a creator.
Right.
The difference is the Big Bang is supported by data.
That's right. We did not take a leap of faith. Right. We did not take a leap of faith that was not evidence-based. That's the fundamental line.
Well, that's what I'm saying. You could see it. You can see it. You can actually see it.
In the middle of the 20th century, a pope actually said, you know what? The Big Bang has been shown scientifically to be true. Therefore, God exists. Now, that is a leap of faith.
I would mention two things. Number one, for the 20th century, I would say the discovery that the heavy elements in the universe owe their origin to heavy stars, massive stars that have manufactured them in the crucibles of their nuclei.
Yeah, Burbage, Fowler, and Hoyle. Yeah,
and
marvelous work.
Scatter that enrichment across the galaxy, allowing complex molecules. And in the limit of complex molecules, you get what we call life.
Damn.
That discovery borders on the spiritual, enabling us to recognize that we are not simply alive in this universe. The universe is alive within us. We contain the ingredients of the stars. That is a kinship that some people use it to feel small, but I use it to feel large. When I look up at the night sky, I feel a sense of participation in the great unfolding.
Y'all not so special. Y'all not so special. All that stuff is inside me too. Okay.
We are as amazing and as ordinary as every star in the sky.
Wow. I love that. That's so cool. That's great.